Hello everyone, I'm Shubhika Chenna from grade 10 and today I'm going to talk about the topic which is the first lesson of our science chapter, which is chemical reactions and equations. Let's get started. So first let us know what is a chemical reaction. So a chemical reaction is nothing but it is a change of a chemical substance into a new chemical reaction by making and also breaking the bonds between two or more different elements is called a chemical reaction. The symbols which we use to represent is S is solid, L is liquid, G is gaseous, AQ is aqueous. Here aqueous, it is a solution in which the solvent is always water. So let me show you how do we use these symbols in the equations. So yes, if we take Mg, it would be a solid, then plus O2 would be gas, which gives MgO, magnesium oxide, which is also a gas. So I hope you understand why do we use these symbols. And aqueous also we use it in different times. So yes, parts of a reaction. So we are going to see what are the parts of a reaction. There are only two parts. This the first part Mg plus O2 on the left side would be called the reactants. Then here MgO on the right hand side would be called the product, where when Mg and O2 react we get magnesium oxide. Let's move to the next one. Yes. Now let's see like how to balance chemical equations. Yes. So here we take the reaction which is equation which is Fe2O3 plus C, which gives Fe plus CO2. So first when we see on the reactant side, Fe is 2, O is 3, C is 1, and on the product side Fe is 1, O is 2, and C is also 1. So these are not balanced. In order to balance them, we need to add some of the atoms. So here as we have Fe minus 2 and Fe is not minus, sorry, Fe is 2 and Fe is 1 on the product side, we can simply add into 2. This method we don't have basically any formula, but we use a trial and error method for this. So let's see, when we put 2 Fe here, yes, now it is balanced. But the thing, next we go to oxygen. So if we have 3 and 2, simply multiplied by 2 and multiply this by 3, it would be 6. Yes, in order to get 6 on the reactant side we have 3, so we need to multiply it by 2 and we would put 2 in here. Yes, 2 in here. Then it would be 3 into 2, which is 6 for oxygen, but there would be a difference for iron. Fe it is 2 here, and when we take again 2 here, it would be 2 into 2, which would be equal to 4. So now we need to balance it even on the product side. So for that, we would multiply it by 4. This is what I was saying. We use a trial and error method for the balancing equation. So let's put 4 here. Then this would also be 4 and Fe is balanced. Then when we see here C, which is carbon 1 and 1, it is already balanced. But as we have O2 here, O, O is 2 into 3. So here also we need to balance the oxygen. Only on the reactant side we have balanced now, and now we need to balance on the product side. So in order to get 6 on the product side, we need to multiply CO2 by 3. So when we do it, the whole thing will be multiplied by 3. So the carbon atom is 1, so it would be 3 into 1, which would be 3. So even on the reactant side, we need to get it 3. So we do it into 3 here. It would be 3 carbon atoms. And the final reaction, as you can see here, it would be 2Fe, 2O3 plus 3C, which gives 4Fe plus 3CO2. Yes, I hope you understood how to balance equations. Let's move on to the next one. Yes. So here, let's see, why do we need to actually balance the equations? So everyone, you might know the law of conservation of mass, I think. So whoever don't know, let's see. Law of conservation of mass states that mass can neither be destroyed nor created in a chemical reaction. So we cannot create mass or destroy it completely in a chemical equation. So to obey this, in order to obey this law, we need to balance the chemical equations. So the number of atoms in a chemical reaction must remain the same on the reactant side and product side. As I said in the before slide, LHS should always be equal to RHS so that we balance the equation. Now we see the types of chemical reactions here. Let's move on to it. So types of chemical reactions. We have many types, like hundreds and thousands we have, but the main six types which we have in our 10th class now in our textbook are these. Actually, we only have five of them, but I have included combustion reaction as I thought that it would be important for us to know. So there are six main types of reactions. The first one is direct combination or synthesis reaction. Actually, we only have it as combination reaction, decomposition, displacement, double displacement, oxidation, and reduction. But I have also given the other name so that if in the exam we get the other name, you won't be confused. So the direct combination reaction or the synthesis reaction we can say. Then the next is decomposition or analysis reaction. The next is single displacement or substitution reaction. Then it is metathesis or double displacement reaction, oxidation reduction or detox reaction, and the last is combustion reaction. So first let's see the direct combination or the synthesis reaction. Yes. So the direct combination or synthesis reaction, as we can see, it is a reaction in which combine two or more reactions combine to form a single product. So here it would be in a form of A plus B, which gives AB. As you can see the example here, we have carbon, oxygen, which gives us CO2, carbon dioxide. So here we have one carbon atom, one oxygen molecule, and the compound we get is 2, which would be one carbon dioxide molecule together. As we can see here, the balance chemical equations with physical states. As I said, S is solid, G is gaseous, and even the product side, it is G is gaseous. The next, let's go to the decomposition or analysis reaction. In this decomposition or analysis reaction, we have three main types, which is thermal, which is carried out by heating, then electrolyte we have, and photolysis. Electrolytic, which is carried out by the decomposition is carried out by generally electricity, passing on the electricity. Then the photolysis is carried out by presence of sunlight. So first let's see what is decomposition reaction. So in this reaction, a compound splits into two or more substances. As you can see, the compound can split into two or more substances. And the way we write it is A is like if A is a compound, it will be split into B plus C. The types we see is the first one, as I said, it is carried out by heating. An example we can take CaCO3, calcium carbonate, and which gives us CaO, calcium oxide, and CO2, carbon dioxide. As we see, one compound is split into two of them. Then we go to electrolytic reaction. which is when the decomposition is carried out by passing electricity. So as you can see, hydroelectricity, H2O, in the dams they make electricity through water, right? So they use this way. By passing electricity, we can uh, separate this compound as H2O, which gives us H2 and O2. Then we go to photolysis. It is the decomposition which is carried out in the presence of sunlight. As you know by the name only, photolysis, photosynthesis, which is carried out by sunlight, and this also photolysis, which is also carried out in the presence of sunlight. So let's see an example for it. Ag, which is AgCl, which Ag is silver and Cl is chloride here. So this whole compound is breaking down into silver and chloride here due to the presence of sunlight here. Sunlight. I'm not able to draw, sorry. Yes, sunlight. So this we can use it in black and white photography where we have the cameras and all. So let's move on to the next one. Yes. Yes. The next type is single displacement or substitution reaction. So the reaction in which more reactive element displaces less reactive element from its solution. Displace is just separate. Displace literally means separate. So here we see take an example of ferrous, which is iron, plus CuSO4, which is copper sulfate solution. So your copper sulfate solution would be in the liquid state here we can see, and Fe would be in the solid state. Yes, so here as we can see, Fe is more reactive metal than Cu. So as it is more reactive, it takes away SO4 from Cu and Cu would be left out alone, whereas FeSO4 iron sulfate would form a particular compound. So this is the single displacement. Then we go to metathesis or the double displacement, as we can say. Here in a this is the reaction in which new compounds are formed. New compounds are formed by mutual exchange of ions. You know what are ions? Between two compounds. So let's take an example. Sodium sulfate and barium chloride, we can take it, plus barium chloride, which gives us barium sulfate plus NaCl, sodium chloride. So here, as we can see, there is an exchange of ions between barium and sulfate. Yes. So let's move on to the next one, which is types of chemical reaction. The next is oxidation or reduction. Oxidation, I would like to add some more points. First, let us complete with this. In a redox reaction, the oxidation numbers of atoms are changed, and the redox reactions may involve the transfer of electrons between chemical species. So here first let's understand what is oxidation in general. So this oxidation is the addition of oxygen to a substance or the removal of hydrogen from a substance. Addition of oxygen or removal of hydrogen. So this would be the most important thing for oxidation, where we need to remember what is oxidation. Then when we go to reduction, it would be the addition of hydrogen or the removal of O2 would be called as reduction. These are the two simple differences which we can state when we don't have any other. Then let me give an example of this. So we have CuO plus H2, which gives us Cu plus H2O. Yes. So here the reduction is happening where oxygen is taken out, which is removed in this product side, where we have it in the reactant side. Here oxidation is happening, and at the same time we have H2 where, sorry, this is the reduction which is happening, and hydrogen where the oxygen is not there and it is added. As we know, oxidation is the addition of O2 or removal of H2. Here we have addition of O2, so it would be oxidation. Yes. Let's see the combustion reaction. Combustion just generally means that burning. Combustion is burning. So a combustion reaction is a type of redox reaction in which a combustible material combines with an oxidizer to form oxidized products and generate heat, which is exothermic reaction. So let's take an example of this. C10H8 plus 12O2 gives 10CO2 plus 4H2O. So this was one of the example of combustion reaction. The next we go, which is the effect of oxidation in daily life. This is important to know, and this may be also asked in our classes or while generally when they are asking. So you all must know corrosion. So if some metal object is left out in the sun, the rain, and the moisture and the air which is blowing, due to that there's a thin layer of oxide forming on this, which is in brown color, like brownish red color, and this leads this is called corrosion. So the general we know is the rusting of iron, and I have also given two more examples here, which is black coating on silver and the green coating on copper. So in order, like, if we don't want our iron, silver or anything to get rusted, when we are putting it out, we can just simply paint it or grease it. Yes, so we can simply paint it or grease it. Yes. The next we go, which is rancidity. I think you must have heard this term for the first time, some of the people. So let me say it. The oxidation of fats and oils when exposed to the air. This leads to bad odor and taste of food. This leads to bad odor and taste of food. Just a minute. Yes, this leads to bad odor and taste of food. So we can take an example, which is the chips packets, which are saved from rancidity by filling nitrogen gas in them. So let us see what if the nitrogen gas was not filled. Let us take it as chips packet. This is a chips packet. So the first, we know that in the packets it would be oxygen filled in it. Oxygen. If the oxygen, if the chips are exposed to the oxygen, there would be rancidity. In order to save the chips and also remove the bad odor or taste of food, the manufacturers or the company people fill in nitrogen gas in it. As you can see, that's why the Lay's packet would be bulging out, but in that we don't have much of the chips. Because due to this, we can have bad odor and taste of food, so they remove the oxygen air and they fill in the nitrogen gas. Let's see the next one. Yes, we come to the chemical reactions which are based on temperature. As I was saying, we have many others except the six when we are talking about the chemical reactions. So let's take the first one, which is exothermic reaction, which is reaction in which heat is released along with the formation of a product. So when a product is forming, along with it, heat is also generated or it is released. So if we take an example, we can take it as burning of nitrogen gas. So the formula which it is carbon hydrogen CH4 plus 2O2, which gives CO2 plus 2H2. Then it is basically exothermic is the heat is the inside of the thing is hotter than the surroundings. Heat which is hotter than the surroundings. So the next we take it as endothermic. The reactions which require energy in the form of heat, light, and energy. So example we can take it as decomposition reaction, as we saw the photolysis, electrolytic, and also thermal heat, light, and energy. So that would be an example for it, where in the endothermic the surroundings will be hotter than the thing inside. When we put it in a test tube, it would be in the test tube, whatever is there would be cooler than the surroundings. We can take an example of ice pack on our head or on our leg when we get a hurt or when we have a slight swelling. So that's it for today. Thank you for watching.